450 newtons minus mgy. It's actually going to be, m is 20 kg, then 20 by 20 times 9.8, that is going to give us 196. Minus 196. It's acting in this direction, so it's going to be cos 45. Oops. I may not say this component. $450 and 45 minus 196 cos 45 degrees, such that Fn is going to be equals to, we sum these two forces, we're going to get what? 196 cos 45 plus 450 sin 45. 456.79. 456.79. This should be in newtons. Then we sum these forces in the x-axis. So in the x-axis, what forces do we have? We have this force in red going downwards towards the negative, and this force going to the positive. Then we also have the component of the force being applied and the component of the weight of the box. So summation of forces in the x-axis should be equals to MA, second law of motion. So this is also equals to the total sum of these forces, the vector sum of all these forces. Just say vector sum is equals to, we have this force due to this guy.
Due to which guy? There are no guys there.
Okay, since there are no guys, I am sure you are just joining us right now. This guy is Fx. Fx in the positive direction. Then we have minus mgx, which is in the negative direction, minus say F, which is the frictional force. So these guys should all be equals to AM, which is acceleration times the mass. Fx we have, it's this value cos that angle. 450 cos 45 degrees minus mg. Mg, it's actually 196, which is the weight. 196 sine that R angle, which is the same value, sine 45, minus Fn. It's going to be equals to the acceleration we are given, it's 0.7, and the mass was 20 kg. So we make F for the subject, which is just the frictional force of the subject, so that we have F is going to be equals to taking this guy to the other side and this guy to the other side. We have 450 cos 45 degrees minus 196 sine 45 degrees minus, that's 0.7 times 20 kg, giving us 165.61. So it's going to be a positive value, 165.61. 0.61 newtons. Then from the equation to find the formula for finding the frictional force, we know that frictional force is equals to mu, which is the coefficient of whether it is static or kinetic friction, times the normal force. So from our calculations, we found the normal force and the frictional force, and we are being asked in this question to find the coefficient of static friction, which is actually equals to F, which is the frictional force divided by the normal force. This is going to, our F is 165.61 newtons divided by 456.79. Can somebody work out that on a calculator and give us what answer that gives us? Has anybody with a calculator there?
Yeah, we can see the figures, sir.
Oh, you can't see the
Yeah.
figures. I'm sorry. Those are the figures. Okay. 165.61 newtons over 456.74 or 79 newtons. The newtons will cancel definitely, telling us that the coefficient of friction is unitless.
At 0.36.
Sorry, madam, your audio is breaking. You were saying a 0.36 what?
0.36255.
3255. I don't know if this figure goes on, but I'll end there. If you want, given the number of significant figures or whenever you're told to solve these questions, you'd actually be told how to specify your answers. They would either say to certain number of significant figures or this number of decimal places. But since we are not given, we can either leave it like that or round it off to the stated number of decimal places or significant figures. So this would be our coefficient of static friction. Are there any questions in regarding this particular problem we are dealing? Did you have something, Mr. Senyango? Okay. Take it that there are no questions. Then from this point, I think we are just remaining with about 15 minutes before this meeting ends. Let me try to see if we can solve another question But in this case, is there any particular question that you can solve that seems challenging to you guys from this tutorial sheet or from any other bank of questions that you have that I can do in 15 minutes?
Yeah. What about question please?
Question
Three.
Question 3. Okay, let's
Yeah.
see if we can do question 3 in the next 15 minutes. So question 3 reads, the rear side of the truck is open and a box of mass 20 kg is placed. So the first thing you need to do every time you're reading a question, just pick out those key points you're trying to get. Says the rear side of the truck is open. A box of mass, definitely we need a mass at some point since they told us a mass. It's 20 kg is placed on a truck 4 meters away from the open. So it is 4 meters away from the open. So it means whatever happens, if you were to push this box out, you would push it over a distance of 4 meters for it to fall off the truck. If the truck starts from rest with an acceleration of 2 meters per second squared on a straight road, find the distance the truck will travel when the box will fall off from the rear, given the coefficient of static friction or kinetic friction is actually 0.15. So since this truck is moving in this direction with this particular acceleration, and we have the mass of the truck and the box inside, do we have the mass of the truck? We do not have the mass of the truck. This question seems interesting. So what do we do? First thing first, Newton's second law of motion. Should I use this same area to write, or I can move on to the whiteboard? Let me move on to the whiteboard. I think that would be more convenient. So we are doing question 3. I think we have enough time. Just in case for this question only, if time ends, if this meeting ends, I think you can just rejoin. I'll spare 5 more minutes. So we sum up, before we even sum up, let's have a free body diagram for that box. So we have this box. It's laying on this ground, and they've even told us that there's like a distance of 4 meters between where the box is placed and where it might just fall off. So this is the rear of the truck. Just considering the rear of the truck in this case. All I need is just a free body diagram. We need to even bother doing all these things. Let me set up my axis. I'll set up my axis in pink because I like pink. So let me consider this as my y-axis and up is positive. Let me consider this as my x-axis. And in this case, I'll consider this going this way as positive, the acceleration going this way as positive. Say this box is moving this way. So now let me try to resolve those forces that are acting on this box. So we have 1, the normal force. Let me call this guy Fn. The other guy is the weight, the box. Let me call it W. Then this box would actually be moving in this direction since the entire truck is going in the opposite direction. Let me just use another color so that there's a distinction. So this box would actually be moving in that direction. Let me call this guy F box. So I would say it's FB, not Facebook. Then the frictional force would actually be going in the opposite direction, which is F. Okay. Now, what do we have? What do we know about this? We know that the summation of forces in the y-axis should be what? 0. Summation of forces in the y-axis should actually be 0 since there is no motion. And in this case, we just have Fn minus the weight. This is just going to give us what is our Fn. We don't know what Fn is. Just let's say equal to here. Let me say implies that Fn is actually equals to the weight. And the weight is, we have a 20 kg box and our gravity, let's take 9.8, so that together this gives us 196 newtons. I only have 10 minutes. I hope I'll finish in the next 10 minutes. 196 newtons as the normal force. Then we come to the x-axis. In the x-axis, there's some sort of motion in this case. There is F and FB. So summation of forces in the x-axis. In this axis, we have motion. So it means the summation of these forces would actually be equals to mass times acceleration. From the second law of motion. Then what are these forces that we have? We have this force F going in that. We have FB minus the frictional force, which is F. If you remember the formula for the friction from the previous board, this guy is the same guy we are going to use. F is actually equals to Fn times mu. Our mu was given as 0.15. So our frictional force in this case is going to be, let's Fn is 196 times 0.15. Somebody confirm that when you multiply these times 0.15, it gives us 29.4. That is what my casual calculator is telling me. This is going to be in newtons. That's the frictional force.
Yes, that's the answer.
Okay, thank you very much, Madam Jane. From the question, I'm sure we are told what acceleration was, or if we are not told, then we have to find it. Let me just go back to the question and we read the question. So let me say acceleration times mass is going to be equals to FB minus 29.4 newtons. Let me just go back to the question and read what the question is asking me. It says the rear track, the rear side of the track is open, blah, 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 2 meters per second. Mass of this is 20 kg. Yeah. So what is this force? This force that we have as FB. Since we know the acceleration of this track and the mass of the box. Force is equals to mass times acceleration as well. So FB is equals to 2 meters per second squared times 20, which is going to be a 40 in this case. So FB is equals to mass of the box times acceleration over that particular track. How fast is that track moving? So we have this acceleration, we don't know. It's the acceleration with which the box would move, but the track is moving at a certain acceleration. So this is the mass of the box, which is 20 kg. It's equals to the mass of the track times that acceleration of the track. The mass of the box times acceleration of the track is equals to FB, which is 20 times 2, giving us a 40 minus 2.29.4 newtons. When you do your math correctly here, you would confirm with me that you get 10.6 over 20, which is going to give us 0.53 meters per second squared, since this is acceleration. So this is how fast the box will be moving in the opposite direction. Since we have this box here, the box will be moving in that direction, but the whole track is moving in that direction with that particular acceleration. In other words, we're saying this box is being pushed with that acceleration going this way because of its surface, but instead, because it is on a surface with some certain level of friction, it moves backwards. I think you guys, this is actually what inertia is. This is talking about inertia. If you are in a bus riding, if the car is going at a certain speed or velocity in a particular direction, whenever the driver applies brakes rather, we would actually move forward at that particular point instead of, because of our inertia. Even if you are seated tight, you'd actually move forward, hence the seatbelt mechanism to avoid fatal accidents. Hope it's making sense. So we have our acceleration here, and the question is telling us to find how far, find the distance the track will travel when the box will fall off from the rear, given that particular coefficient of friction. So we have acceleration. Going back to the laws of motion, it says the track starts from rest. So whenever something starts from rest, it means your initial velocity, say VO, is actually equals to 0. Then we have that formula. You can say D, which is the displacement, is equals to initial velocity times time is equals to, oh, not equals to, but plus 0.5 acceleration time squared. Using this, we can be able to find time. Oh, since we need this distance, we do not have the time. Let's see if we can find the time. Since this distance the box moves is actually 4 meters, then the initial velocity is 0. So this guy will be 0, remaining with just a 0.5. Acceleration, what is the acceleration? Acceleration, we found the acceleration to be 0.53. What is the time? We don't know. That is what we are trying to find. When you do your math here, 0.5 times 0.53, 0.53, that would give us 0.265. So this guy 4 is equals to 0.265 t squared. Then our time in this case will be equals to the root of, in this case, we just need the positive value. Time is never negative. 4 over 0.265, which is actually going to be 4 divided by answer, the root of answer, which is going to be 3.885 seconds. 3.885 seconds. Just in case the meeting ends, please join in case I don't finish this question. This is the amount of time it took for the box to fall off. Now, how far did the truck travel for this during this particular time? Using the same formula. D is equals to VO times T plus acceleration time squared divided by 2. This is 0. What distance do we need? Distance is what we are looking for. This is 0, so this whole thing is going to be 0. The acceleration of the truck was 2 meters per second squared